Hello, everybody. This is Miss Peachy from WCA Astronomy 1A, and today I'm doing a tutorial on how to do this portfolio in Unit 6, Lesson 10. This is Activity 2. This is where you're going to be looking at a specific white dwarf star, and you're going to kind of determine some things about that star. So this is a bit of a tricky portfolio, and you're really going to want to watch this video closely. I have some shortcuts for you, some things that'll make it a bit easier, but without the aid, I think, of this video, it might be very, very difficult indeed to figure out what you need to do. So, first of all, you're looking at a specific star, a white dwarf, which has the name WF4358. It's found in a globular cluster, which the globular cluster is named NGC6397, and that isn't really necessarily that important. So what you're looking at, it says, is the wavelength is tracked on the X and Y axis, or the x-axis, intensity is on the y-axis, and we're going to be paying attention to the wavelengths that have the highest intensity. So we're looking at this picture first, okay? We are not looking at these stars. These are other stars located in the globular cluster. We are only looking at the first star that's shown here, WF4358. That's our star that we're going to be focusing on here. And so what this table is showing you, it shows you the intensity, like how intense, and that's based on peaks. Where you see peaks, that is our most intense absorption that occurs. So there's one there, there's, maybe here, there, anywhere we see like a peak. Those are our intense, the highest peaks. And that is graphed against a wavelength. So you can follow that peak down and you can determine the wavelength that it occurred at. So I'm going to zoom out a little bit on this one just so that we can kind of see both the wavelength and the peak in the same shot. So for example, let's look at this peak right here. You see that peak? If I follow that down, straight line down to the x-axis, it intersects about there. And again, that's a little bit of an estimation, but that's about where it intersects. Each one of these lines is 10. So this is 410 and 420. So it's intersecting at about 420. So I can use this peak as one of my peaks and say that it has a wavelength of about 420. I could use this peak as one of my peaks. So you really want to use where you have kind of your highest peaks here. So we might want to use this guy, and this guy, kind of our highest, most intense, because intensity is increasing in this direction. So this is definitely the most intense one right there. That puts us at about 380 or 390. Yeah, about 390. So that being said, you're going to create a table. In fact, you don't have to create the table because I did the work of creating this table for you. So I've created a Google Doc for you to use, just like we have in the previous portfolios. And you're going to pick those 3 peaks, and you're going to follow the peak down, and you're going to put the wavelength in here. Okay? And then the next thing you're going to do is you're going to determine which element you think corresponds with that wavelength. So going back to here, we're going to look at this next picture, and you're going to see if you can find a wavelength that's close to the one that we had identified. Now, I said, 380, 390. I don't see one there. The closest one that I see here is argon. Argon is 364. So that's as close as, I can see. So on my Google Doc, I put the first wavelength that I identified was 380, 390-ish, around that range. And according to that one graph, I think it's argon. And then it's going to ask you for the frequency. It says, this is where it gets to be a little bit murky. It says on here, let me just bring that up here again. Okay. It says, do some online research to find the frequency of the 3 wavelengths you identified. Well, that's kind of vague. So what I've done is I've identified a website that you can use, And let's see, let me bring that up again here. Right here. You click on this link here to this website. It's going to take you to the wavelength calculator. And you need to be changing a few things here. So we have wavelength, but we need to figure out what the frequency is. So I'm going to take this little drop down and I'm going to say, I want to calculate frequency. So I'm going to select the last option. I'm going to put the wavelength in, and I said it was around 390, right? I could split the difference and say 385 if I want to here. You will always put in here for velocity for every single one of these 300,000. And the reason being is because that is the velocity of the speed of light. Oh, by the way, this 385, I want to calculate. I'm going to change the label here to NM, which is nanometers. So you're going to change that to nanometers. Always put 300,000 in here and then hit calculate. And it's going to give you the frequency in hertz. I'm going to take this frequency and I'm going to just copy it. And I'm going to paste it into the document. Just like that. Now, once I have the frequency in hertz, this number here, I'm going to use this next link, Planck's equation calculator, to enter my frequency in. So it gives me Planck's constant. I just have to put the frequency in hertz. We just calculated. And then it's going to give me the energy of the photon, which is right here. And then you can put that right in column 5. Okay? That's 5.166 blah, blah, blah times 10 to the negative 22. So we can write it just as this, that's fine. But then you can get the frequency and get Planck's constant without having to do a bunch of calculations and not having to use exponents in your calculations and stuff like that. Okay? So that is what you're going to do for 3 different peaks. Now, that's the peak that I chose. You don't have to choose that peak. You can go back here and you can really pick any of these as long as you're using this first star. I wouldn't pick any line, but pick any peak. So here, you could pick this peak, you could pick that peak. The most intense ones, they kind of want you to focus on those. So this one is actually a fairly intense peak too, right? But they should correspond to one of these elements here. When you're finished with that, you are going to answer 2 questions. These reflection questions, which are written at the bottom of the sheet as well. Would you expect the spectrum of a black body radiator to have peaks and valleys like the spectrum of WF4358? Why or why not? And remember to go back to the lesson and remind yourself, what is a black body radiator and how does its spectrum differ from a radiator that's not a perfect black body? And then for number 2, pick one element from the chart. How might you expect its wavelength to change if it goes, let's say, travels through the Earth's atmosphere or travels through water in the ocean? So think about how when a hot object is radiating and it travels through something colder, like a cold atmosphere, how does that change the spectrum that we observe? Again, go back to your lesson and review that information that you learned, okay? That's what you're going to answer there. So hopefully that helps, makes this a little bit more manageable, a little bit easier. If you have questions, let me know. Otherwise, I will see you guys in class or in the next video.